Okay, so we are in 5.6, writing and solving proportions. So we're going to talk about some proportions today, which we've talked a bit about already this year. I think, hopefully, it's something you're feeling strong about. I mean, when you think of a proportion, what comes to mind? What do you see in your mind, Teddy?
Fractions.
Fractions, how many? One? Is one fraction a proportion? Usually we see two, right? Two that are equal to each other. So two ratios, also known as fractions, that are equal. So as a rule, we could just use some letters like A over B equals another fraction, C over D. When we use variables in a rule, though, what do we usually see? Who remembers? Aiden. He says the denominators may not equal 0. And that's because if the denominator was 0, if you have a 0 under here, that fraction is undefined. Very good. Okay? So when we set up proportions, if you have to set one up for a real world problem, make sure that your like terms are paired with like terms. There are many ways to set up proportions to answer problems from the real world. We can look at some different ones for this problem here. You'll have to write the problem out in your notes or you won't know what we were setting up a proportion for. This says, what if some ants weigh only 1/10,000th of an ounce, but can carry about 5/1000ths of an ounce? If a person were proportionally as strong as one of these ants, how much weight could a 100-pound person carry? So pause the video, make sure you write that down, and then we'll look at all the ways you could set up this proportion. Okay, how would you set this up?
So, I figured out that 0.001 times 50 equals how much it can carry.
Okay, but I want you to set up a proportion. So if we begin, I think I have to calibrate real quick. So just a second, let me pause this. Okay, so Emily is setting it up with the weight of the ant over what it can carry equals, you're saying 100
over 5,000.
over, where'd you get the 5,000?
Because it's,
Do we have that in this problem?
divided.
No, we don't. We have an unknown, right? So you're now trying to fill it in with an answer, aren't you? You're telling me what it equals because you did some process. But before you even do any process, here's your proportion. So the way that Emily set it up was she put the ant over what it can carry. What the ant can carry, she says, should equal the person's weight over what the person can carry. Okay, who else set it up like that? Okay, there are other ways to set up. Give me a different proportion. Jake.
Same exact thing, but X over 100.
So if we put X over 100, we now have the weight of the person under what the person could carry. So what would we have to have on the left side?
0.005
Right, we would have to have the weight of the ant underneath what it can carry, right? This is the same form, do you see that? So instead of having what the ant weighs on top, we moved it to the bottom. What it can carry is on top. What the person can carry is on top, and what the person weighs is on the bottom. And these both are great ways to set up this proportion. There are other ways too. Can anybody think of another way? And then we'll talk about solving it later. I mean, I'm sure you can all solve it. But Brian. Okay, so if you have, he says, if an ant weighs 0.0001, right? There's the ant, and the person weighs 100. And how would you have to set up this ratio? 0.005 over what the person can carry. So in words, this proportion says the ants can carry, now wait a minute, is this what the ant can carry? This is their weight, right? Ant's weight is across from what the ant can carry, which is true as long as you have the person's weight. I didn't write weight in those other ones, did I? Across from what the person can carry. Do you see that there's still like parallel structure there? Okay, and then the final way that we could do this is, couldn't we flip both of these? Right? We could say that what a person weighs is related to what they can carry, just like what an ant weighs related to what an ant can carry. Again, the ant is in both cases on the bottom there. Okay? So there are, look at that, so many ways you can set up a proportion and still have a true statement. All of these are true. And so it doesn't matter which way you choose, as long as you choose a true way to write the statement. Let's talk about a false way to set up the statement. How could you, let's put a little spot down here, right? One little false way to set up this proportion. If we have what, let me start this way. If we have what the ant weighs over what the ant can carry, what might be a mistake a student would put on the right-hand side for that ratio? If we have the ant weighs over the ant carry, then we would have to have what, Izzy? Say it again. If we write it the way you're describing it, isn't that what we have right up here? That's a true statement, okay? We're thinking about a false one. What the person can carry over what the person weighs. You see how this is not true? Strike out that equal sign. There's not a like parallel construction there. We have the ant's weight over what the ant can carry. So we should have the person's weight over what the person can carry, right? And that's not what's seen in that one, so this would not work in finding our unknown for this question. Okay? And let's go ahead and find that value, which probably you already know. It still sounds like a lot. I don't know. How did you find it? Let's go back to the original equation that you gave us, Emily. I'm going to erase these things and solve this so that we can find what a person can carry. Oh, well, maybe it is. This was based on what an ant can carry, right? So remember, an ant can carry, you probably already know, quite a lot compared to its weight, right? So how did you solve it? Did you divide it into the top? Okay, and sometimes when people have decimals in the fraction, sometimes people blow them up, right? We could blow up this fraction here by multiplying the top and bottom by 10, 100, 1,000, 10,000. See that? How many places did I move that? 4, so we would move this 4. 1, 2, 3, and 4, put a 0. So we have 1 over 50 equals 100 over x. Right? So when we find x now, how would you like to find x now? Hey. Okay, so you bring the x up. 1 times x is x. And 50 times 100 is? Which is what you said, Emily? 5,000. 5,000. So can you go out and carry 5,000 pounds? 5,000 pounds. If you were an ant, if we had the strength of an ant, we could carry 5,000 pounds. If we weigh 100. If we weigh more than 100, which I admit I do, weigh more than 100, I should be able to carry more than 5,000 pounds. Isn't that amazing? What an ant can carry. So ants are amazing. Okay, let's go ahead and solve a few proportions, and you're going to be given proportions to solve. So how do we solve this proportion? What would you do? There's more than one way, right? And this one, probably you would all agree we would do what? Here, Kenzie. How would you simplify that? You would cross multiply? Okay, you could, and we're going to talk about that. That's important. And so she would go 4 times n, or n equals, what is 12 times 3? 36. And then what, Kenzie?
Then I would divide for both sides.
And n equals 9. Good. This is true. If you chose to blow it up, you could say 4 times what is 12? 4 times 3. So 3 times 3 is?
9.
So n is 9. And you may just blow it up if you see that. Okay? And so here we go. What's the first thing a person could do in this case here? Do you see it? Gabe.
Subtract 4.
I'm looking at number 3, and looking at 50 over 20, what could you do first?
Oh, simplify it.
You can simplify by what?
10.
10. So divide them, and you have 5 over 2 equals z over 16. And then how would you do it? Would you cross multiply, or would you blow this up?
Let's multiply.
2 times what is 16?
8.
So 5 times 8 is what?
40.
40 equals z. You just did that by blowing it up, you see? You could cross multiply, but you don't need to if you have factors that are easy to blow up, okay? So let's talk about the cross product property. You seem to be strong at this. We're going to be really needing it when we see variables going on and more than one operation taking place in a numerator or denominator. So remember, the cross products of a proportion are equal. So that proportion we just saw, if A over B equals C over D, then we can say, who could finish the rule? Then AD equals BC. Okay? In the left side, we have B minus 3 in the numerator. So this is definitely a 7th grade proportion compared to 6th grade. We have 2 things going on in that numerator. So we have to be super careful when we use our cross product. We're going to do what you're used to. We're going to bring the denominator up and over. But remember, a fraction bar like this is a grouping symbol. Okay? And you don't see those parentheses, but you need to add them in. Because when we bring that 5 up, we're multiplying it not just to B, but we're multiplying it to B and the negative 3. Yes, that is a negative 3, isn't it? Okay, so we can change subtraction to adding the opposite, in case you are wondering why I said negative 3. Remember, all terms are either positive or negative. Okay? And so now, what do we have on the left side here when we do this distributing? Kenzie? 5b plus a negative 15 or minus 15. Good. And then over here we have 80. And now we're back to a 2-step problem. And so how do we undo the negative 15? How do we undo the negative 15, Spencer? Good. Add 15. That's the inverse of negative 15. And then how do we undo the 5? Is he? Divide by 5. And that leaves us with B equals, I think it's 19. Did anyone get 19?
Yes.
Okay. Which, of course, we can check back in the original. What is 19 minus 3?
16.
Is 16 over 20 the same as 4 over 5?
Yes.
Yes, it is. Good. So we've had a good check. Okay? Okay, here we see 2 terms in the denominator now. So what should we do first? What do you think, Will? Okay, this entire term needs to come up here. So we can write that as 8 times x plus 1, the whole thing. This part's easy. We just have, good. Do you know what 16 times 3 is? 48 equals, and now tell me what we do over here.
Oh.
Plus 8, good. And now here we have a simple 2-step problem to solve. And so there you go, just use your inverse operations. We can check this answer in that problem. Is 16 over 5 plus 1 the same as 8 over 3? Is 16 over 6 equal to 8 over 3?
Yeah.
Yes. Good, it's true. Okay, you can take this down, pause the video, and come back and see the work that we've done here with these tricky ratios. It's such a small thing, but putting parentheses around expressions that have addition or subtraction is your first step. Then we can move to cross product. Okay, so there you go. We distributed and discovered that x equals 1/7. Okay, here we have the final question, and then you have your assignment. Look at that. Very fun question. Find x and y. Okay? We can't, we need to find x and y. And so where do we start here? We just had a problem back here where we had x's on both sides. Were we able to find x?
Yeah.
Yes. So as long as we're only with one variable, we can find it, right? So where do you think we should start here? Spencer? Okay. And so we're going to figure out first what?
4 times, oh, parentheses.
4 over...
Oh, parentheses.
Good, so just start there. Start with that proportion. If we can find x, we'll actually know what either of these ratios actually equals, right? If we can find x, we could just name this fraction. Okay? So let's just solve that first. And then we'll go use the answer we get from here to solve for y over there. Okay? So use your cross products. Bring this up. When you bring this up, what do you have on the left side, Colin? What is 4 times 2x?
4 times 2x with parentheses.
Okay, I'll write it. 4 times 2x equals 3 times. Can you tell us what 4 times 2x equals?
8x.
So we have 8x equals, what do we have here?
3x and negative 15.
Good. And now which side has a greater number of x's? The left. So let's move the x's to the left. How do we move 3 x's to the left? What's the inverse of 3 x's?
Minus 3x.
Minus 3 x's, right? They're an entire term. We can subtract it. And we have 5x equals, what's left?
15.
No.
Negative 15.
Negative 15. Good. And now to finish, divide by 5. Good. X equals negative 3. Okay, so we have x equals negative 3, which is one answer, but we need to find y. So if we bring this up here, we can actually set up the second proportion, right? Put these two together, but instead of having 3 over 2x, we have 3 over 2 times, what was x? Negative 3. We're plugging it in, see? And now we're going to find this other variable y. You see that? What is 2 times negative 3? Negative 6. Okay? And could we do something to make this fraction a little simpler? 3 over 6 is what, Alex?
1 over 3. Negative
It's actually 1 over 2, right? 1 over negative 2. Okay? And now you simply solve for y. So what will we do to solve for y here? Aiden up here.
What do you cross multiply?
And you get 21 equals what?
21 equals... Negative
to get y equals negative 10.5. Okay, good. So you can see that there's a little bit of work involved, but you have everything you need to solve a 3-part proportion like this. Just treat them as 2 separate proportions. Okay, there you go.